Question 16. What volume in milliliters of 0.750 molar NaOH is required to titrate 100 milliliters of 1 molar H2SO4 to the equivalence point? Okay, so this is an acid-base titration question, and it's important to, when you're doing these types of problems, it's important to understand like the theory behind acid and base titrations. So what happens when an acid and a base react is that the acid releases hydrogen ions into the water, okay? And the base is going to release OHs. So the hydrogens have a charge of plus, and the hydroxides have a charge of 1 negative. And when these things react together, they just form water. So they neutralize each other. And when you have a titration, the goal is to neutralize all of the acid and all of the base. Okay? So just keep that in mind as we do this problem. So the acids that they gave us are 0.750 molar NaOH, and we don't know the volume. And then they also gave us 1 molar H2SO4. And they did give us the volume of that, and it's 100 milliliters, or 0.1 liters. Now remember what that capital M means. M means moles per liter. So this H2SO4 is 1 molar, so that means that there's 1 mole of it in every liter of the solution. So they tell us that we have 1 molar H2SO4, which means we have 1 mole of H2SO4 per 1 liter. Okay? But we don't have a full liter of it. We only have 0.1 liters of it. So if you multiply this by this term, then the liters will cancel out. So for right now, we're left with moles of H2SO4. Okay? So now we can start converting this. We eventually want to get the volume of the NaOH solution. But that wasn't given to us, only the molarity of the solution was. So how can we convert this to moles of NaOH over moles of H2SO4? Well, remember what I said about acids and bases. The acids donate H ions, and the bases donate OH ions. And there has to be an equal amount of both. Right? So if you look at H2SO4, it actually has 2 hydrogens it can give. H2SO4. So this is going to break up into H and another H. Whereas this NaOH only has 1 hydroxide to give up. So it's 1 OH. Okay? So where I'm going with this is that you actually only need 1 mole of you need 2 moles of NaOH for every 1 mole of H2SO4. Because this 1 mole of H2SO4 is going to give 2 moles of hydrogens, which is going to match up with the 2 moles of hydroxides that the sodium hydroxide is going to give. So the moles of H2SO4 cancel out. And now all you need is the volume. So this is 0.750 molar solution. So that means for every 1 liter, you have 0.750 moles of NaOH. So the moles of NaOH cancel out. So now you're up to liters, but they want the answer in milliliters. So multiply that by 1,000 milliliters per liter. The liter cancels out. So your answer is going to be 0.1 times 2 divided by 0.750 times 1,000. You punch that in your calculator, and you're going to get 266 point repeating sixes milliliters, which is closest to answer 5 on your test, which is 267 milliliters.